Hey everyone, welcome to Tech Guru. Here we explore electronics, embedded system, IoT, coding, and lots of exciting projects using ESP32, Raspberry Pi, STM, Arduino, and many more. So if you love learning, building, experimenting, you are in the right place. Let's start learning and creating together. So our next topic is ESP32. So first of all, what is ESP32? Basically, we know that previous microcontroller like Arduino, ESP8266 or Node MCU. So these are also available in market. So why we choose ESP32? Basically, ESP32 and ESP8266 are similar, but a little bit changes. Changes means the BLE because of the ESP8266 or Node MCU, it support Wi-Fi, but in case of ESP32 it support Wi-Fi also, and BLE Bluetooth low energy also. And also here some special means some sensor like touch sensor, inbuilt touch sensor, touch pins are there. Then for the audio communication is there. So let's see what are the benefits why we are using the ESP32. So these are some specification of ESP32. So basically we'll start from the beginning or basic, from the basic to advanced level. So in this we'll discuss about basic programming, then after that we'll start the cloud platforms. So it's a dual core 32-bit microcontroller module, and it's a clock frequency of 240 megahertz. Then some integrated Wi-Fi also there, Bluetooth and BLE. Then some digital and analog pins also there. And it's a successor version of ESP8266. Now up to 18 12-bit ADC is there, 2 8-bit DSC, 10 capacitive touch sensor. So basically it's an inbuilt sensor included in the ESP32. Then for SPA bus, for the SPA communication we have 4 SPA bus channel is there. For the I2C also 2 I2C is there. Then further I2S. So basically I2S to I2S. So I2S basically this is used for the audio purpose, because in the Node MCU we don't have this I2S communication or for the audio purpose, but here in case of ESP32 we have the I2S. And some UART connections are there, then SD card host controller, and here some PWM, and all these things are inbuilt is there. Next, then motor pins are like in this ESP32, all the like the lots of pin, like pins having the lots of pins are there. So some pins having the multi functions is there. So one pin having the multi-purpose, so we'll discuss it later. Some component not can be used simultaneously. So basically we cannot use the some pins, some pins are there, we cannot use all these pins simultaneously. Next, here also some pins are also here some pins are also used for only input purpose. We cannot take this pin as a output. Now these are some variants, the different boards are there. So for the camera purpose we have the ESP32 camera module, and for the display purpose here also there. And these are different types of microcontroller board, ESP32 microcontroller board. Now so this one is the ESP32 pin diagram. So in this pin diagram you can check here GPIO 36, all the pins are there. So GPIO basically is known as the general purpose input output. These pins are known as the input and output pins. Here some pins are having multiple operation, like we are talking about GPIO 36, it's used for only, we can use this pin as an input and use the RTC. So basically RTC is known as the real-time clock, or it's a I2C protocol. Then some sensor and analog pin also this one is. So lots of pins are there, then these pins are having the separate functions. So basically this one is the ESP32 board. It's look like this. Now so here GPIO 36, so different pins is there. In market we have different types of modules. It's depend on the how much pin you require, how many pins you require. That time you have to choose which board you are using. Now this one is the ESP32 board. Actually ESP32 look like this. So basically this is a USB input. So basically this USB port used for the two purpose. First one is the to upload the program. This cable you have to connect to the computer, and another part will have to connect into the ESP32. So basically this cable having two operation. One is to upload the program, and another one is the giving the initial 5 volt operating voltage or 5 volt power supply. So this board is working the 3.3 to 5 volt operating voltage. So for the USB we can upload the program and also giving the power supply. Then boot button basically used for to upload the, when we will start to upload the button, or for the booting purpose we need this boot button. Then en basically is known as the reset pin. En is normal as a reset pin. CP2102 is the driver and some voltage regulator. So why voltage regulator? Because different board having like different sensor having different power factors is there. Like some sensors are working in 5 volt, some sensors are working in 3.3 volt. But if we provide the 5 volt here, then if I have some sensor that it would work in 3.3, but so it's a development board, so that's why we have 3.3 pins also there, 5 volt also there. So for this regulation we have the voltage regulator is there, and all the pins are there already mentioned, the pin number, which one is the power, ground, which is the pin, and all those things already mentioned. Then this one is the ESP ohm32. So basically the controller name is the ohm32. So ohm32 is the controller name, that the main chip, or its board is known as the SoC board. And for the antenna used for the Wi-Fi communication, we are using some Wi-Fi already inbuilt here. So for the network purpose we are using the antenna. Now, so first, basically what happened here, ESP32 is a third party board. So but because Arduino is developed for the Arduino IDE, because in the ESP32 we are using the Arduino IDE only. Okay, so ESP32 it supports C and MicroPython, C or C++ and MicroPython programming. And here Arduino IDE is developed for the Arduino boards only. So what is Arduino IDE? Arduino IDE, it's a software where we can write the program. So basically Arduino IDE supports C and C++ programming language. So basically ESP32 it's a third party board. So we have to give the instruction to download this board. Then after that we will use this board. So how to use this board? So basically in this link we have to copy this link first. So you have to copy this link. After copy the link, we have to go to the Arduino software. So for the Arduino software, this one is the Arduino software. First you have to copy the link, then click on the file. After click on the file, you have to click on the preference. So here preference, some locations are there. Here mention is the font size. So if this font size is known as the, if we increase this one, then your the letter size will be increased or decreased. You can increase or decrease from here. And here this additional board manager, you have to click here and we have to add this link. So after adding the link, we have to click on OK. So when you do this operation, you have to connect to your internet first. So why internet? Because we have to install this board. For the installation purpose we need the internet. So after giving the link, we have to install the board. So basically you have to click on tools, then you have to click on the board in the board manager. So you have to click on, I'll repeat again. Okay, so first we have to click on tools, board and board manager. So it will take some time. After that we have to search here ESP32. After that we have to search ESP32. Then this board we have to select. You can choose the version, then install. After it will take so like 15 to 20 minutes, it depends on the internet. After installation it will give that yes, already installed, because in my system already installed, so that's why it's showing that already installed. Those are doing in first time, it's required to install. Okay, so after installation we can do any ESP32 programming, otherwise it's not possible. So first we have to install the board. So after installation, in case of our Arduino and ESP8266, we have to choose the board. So first here also we have to do the same thing. We have to click on tools. Just 1 minute. So here we have to click on tools, then here board. Already I have selected. So you have to click on board. Then here after installation you have to choose on ESP32 Arduino. after click on ESP32 Arduino, you have to choose the microcontroller. So basically we are using ESP32 dev module. So this one, ESP32 dev module, you have to select this one. After that, you have to connect the your microcontroller board. When you connect the microcontroller board, that time you can check this here one port will be erased, then you have to select this port. After that, that means your board is already connected. After that, we can write the program. So for the program, basically those are know about Arduino and ESP32 programming, they can easily write. If those are not don't know about the programming, I'll explain. So basically in the Arduino IDE is known as the integrated development environment. So IDE means if you open like if I click on file new, so it will give some generated code. So these codes are the predefined codes. We cannot delete this thing. Like here, the double slash is known as the command line. So it's not need. So I'll remove this one. So what is the use of these two? So void setup and void loop. So void setup basically used for the single declaration. Single declaration means if you record once, that you have to put in the void setup. In void loop, whatever you want continuously or infinity time, this thing you have to put in the void loop section. So in the programming, three parts are there. One is the here, one is the declaration. Here this one is the declaration, and the void setup part is the initialization, and void loop part is known as the looping. So programming categorized in three parts. First one is the declaration. Declaration always the top. Then declaration means all like any type of, if you are using any type of variables, some pins, some libraries, so these thing you have to declare firstly. Okay, so that's known as the declaration part. In void setup, we have to initialize something. Like initialization means whatever you record once, like our input output declaration or this type of things. Void loop for the continuation operation. Whatever you are putting in the void loop, you got this value in the continuous manner. So let's check. So already we did this thing. Now the programming. So how to write the program? I'll write the program and I'll explain all those things. So first, what I have to do, I want to LED blinking program. Okay, first. So basically we are going to inbuilt LED blinking program. So inbuilt two number pin in the ESP32 board, like in case of our ESP like Arduino board, 13 number, some different integrated pins are there that directly connect to the LED. So here we have a inbuilt LED is there. The inbuilt LED name is the pin number 2. So how to write the program? So for the input output, because of LED is the output device, so that's why I have to declare pin mode. Pin number 2 is my output. Pin number 2 is my output. If those are having some pins like input pins, so basically output means all the output like LED, motors, these are the output device. Like all, if whatever sensor you are using, sensors are input. So here pin mode basically used for declaring input output. So pin mode always used for to declare input and output. So I already told that all the inputs and output should be stored in the void setup. So now after the void loop, what I have to do, I'll LED blinking like for the after 1 second duration. So first what I have to write, so digital write to number is high. Okay, so basically what is the meaning? So pin number 2 and first already I told that LED. So basically LED is a digital output device. So that's why I'm using digital, right? Because for the output purpose, if you're using some output, that time it should be write operation. Okay, like write always used for the any output device. If you're using read, that means it's known as the sensor. If you're using some sensor, it's known as the read operation. For the output, we have to use write. Digital is known as the for the digital device. Analog, if you're written here analog, so analog means any analog pins. So I want to hide the LED or turn on the LED. So this 2 number is pin is the already we defined pin number 2 is the, so pin number 2 will be high. High means on, or we can write as 1 also possible, anything we can write. But how much time I need? 1 second. So I have mentioned delay 1000. So that means it will be on the LED up to 1 second. Here delay is a predefined function, whatever you have mentioned here na, so it should be a millisecond. Here 1000 millisecond is known as the 100, like 1 second. If you mention 100, then it's known as the 100 millisecond. So like this, LED will be on. After 1 second, LED should be off. So same thing digital, right? So we cannot use here read because we are using output. So we cannot, if sums are doing here, you have to write. If those are writing newly, so they have to already light on na, so we have to light off. So that's why here we have, maybe we are writing here read, but don't do this thing because LED is the output. So output means you have to use the write operation only. Don't use read. Okay, if you are using read, then it will be showing error or you are not getting here. So you can here also you can use 0, otherwise low. So if you are using high or low, it should be a capital format, otherwise you will simply put 1 and 0. After that you have to again give the delay. Why delay? Because I need 1 second duration. Like this LED will be on for 1 second. After 1 second, LED will be for 1 second. It will be repeatedly doing the same thing. So that's why I'm writing the program save. So already we written the program. Now after whatever the program we have completed, we have to save this program. So basically for save, already we know that every C programming, Python programming, any programming language we are using, so some programming having some like the extension. Like if you are using C programming, then in the last you have to put the .c. Okay, so here also Arduino programming. Okay, so the Arduino extension is .ino, but we don't need to give the extension because it will automatically take in the extension. So first you have to save. Click on file. You can save according your location. So after save the program, okay. So after writing the program, so first when you open the software, okay, those are know some bit some about the Arduino software, they can use. If those are new to this, then first you have to choose the board first. After board, then you have to write the program. So after writing the program, you have to click on port, then you have to select the port, because now I didn't connect the hardware, so that's why it's not visible. Otherwise you can check here in the right side, you can show the port, then you have to select the port. So after this you have to choose. Okay, if you are not choosing here the ESP32 and you have written this program, maybe it will showing error. So maybe this program is the basic program, maybe it's not showing error, but for the later some program having some different we are using some syntax, so that time it will showing the error. So first better you have to choose the first your board. Then after checking this thing, okay, after checking all those things, you have to check the program. For the checking purpose, here we are having some operation, like this one is the build operation. If you click this one operation is checking the error, if is there any error is there. So basically the screen is divided into three parts. This screen is, this part is known as the program window. Whatever program you have to write here in this screen. And this color is known as the processing. Already this one the processing is going on, and this one is the error window. Whatever error if you have, it will showing the error. Now my compilation is going on, so after compilation it will take some time. So if you are using some latest version software, it also same, little bit different, but whatever the process is same. No need to change any programming, or all the programs are similar. So after completion this, if you have any problem or any error, it will showing that. If you don't have any error, it will showing that here verification or compilation done. Then after that no, it will take some time. So if you write any program, so first you have to declare all the like in the declaration part, whatever program you are writing, you have to mention or give the title of this program, then it will be better for easy understanding. No, if you have the hardware, then it's also okay. If you don't have the hardware, so if you don't have the hardware, you can use here I'll show you thinker card. Oh, sorry, you can search thinker card. So for the thinker card is a user defined software, sorry, it's a easy for the user if you don't have the hardware. So if you don't have the hardware, then you can use the thinker card, thinker card software. There in the AI tool is there, so you have to, there you can write the program also. Here you can check down compiling. So down compiling means now my program is correct. If you have any problem, like I'll remove this semicolon, again I will check. So if you have any error, so it will show the indication. So we will check this thing, thinker card. This software you can use. There is a web tool, you can easily access. It's a free tool. You have to log in and you can use the output. There you, that time you don't need the Arduino ID. They are also, they separately they have the tool, the programming for the program purpose. So I'm doing so it's the processing. Okay, so processing going on, like what is the location and about all those things. So remember one thing, whatever program, any microcontroller if you are using, like it's maybe your 8051 peak arm esp 8266 Arduino, like STM, any microcontroller they support only, because we are writing in maybe C or Python or Java, any programming language, we are using the some specific extension like C program.c, python.py. So for the Arduino we have .ino, but the microcontroller, the hardware, it will accept only .hex file. .hex means it's a hexadecimal hex. It's not hexadecimal, it's a hex file. We have to upload this hex file. We cannot upload .c or .in or .py file directly. So this is the, like it's showing the error, because here also you can check in the process window expected semicolon before delay. So it will also showing the indication. So after that you have to click on the upload. When you click on the upload, it will take some time and it will upload this code to a microcontroller. After uploading this thing, uh, and now I am not connected, so that's why I connect. But after the compilation, you have to click on the upload. Then that time it will automatically upload. So after uploading the program, so you have to connect the hardware. So for the connection purpose, normal simple thing, already inbuilt LED is there in the board. Otherwise, you can connect the LED positive pins to the pin number 2 and the LED negative pin to the ground. Then it will be giving the output look like this. So basically this one is the basic program. Also in the Arduino software also support some programs are there. If those are using previously, they know about some example programs are there. So you can check some examples program in this software, like click on file, then examples, lots of examples programs are there. If you can try this program. So basically this one is the first basic program. So in the next, so basically I'm not focusing on the basic program because all the basic these lines of codes we are using here. But next session we'll start some cloud platform. Basically this session I am planned for the IoT, basic IoT, like how to control these appliances, maybe it's a AC appliances or DC appliances, any appliances, and with some projects, real-time projects, I'll give some instruction how to write the code, and with the hardware configuration or hardware output. So how to connect the hardware, if those are don't have any idea about the hardware, I'll explain about this hardware, how to connect all those things. So after this I'll next session we'll start a IoT cloud. Okay, so thank you.